Greetings to the lecturers. My name is Vimal with metric number 176410 and my supervisor is Dr. Samsul. My final year project is about carbonization of activated sludge from palm oil meal using superheated water vapor. In order to understand the topic in detail, we simplify it into few keywords. Carbonization is a process of producing carbon. Activated sludge is a solid separated during activated sludge treatment of palm oil meal effluent known as POME, which is from palm oil wastewater. It is high in organic content and can be converted into other useful material. This is a simple illustration about activated sludge. First, palm oil will be extracted from the palm fruit, resulting in POME. This POME will be treated with activated sludge, or also known as aerobic treatment, resulting in activated sludge. Superheated water vapor is actually steam at temperature more than 100 degrees Celsius, in this case at 200 degrees Celsius and 1 atm. Superheated water vapor can dry molecules faster than superheated air because of the high heat capacity of water molecules. It also can heat material without oxidation, and the waste gas produced can be easily recovered by condensation. This is how the activated sludge treatment works. The raw sewage will go into a series of tank before entering the aeration tank. In the aeration tank, organic compound feeding microorganisms will be added to the tank. Once the microorganisms feeding the sewage, it will be deposited at the bottom of the settling tank and then will be transported to the sludge digester and finally to the landfill. Some of the activated sludge will be recycled into the aeration tank in order to maintain the microorganism level. The effect of superheated water vapor on organic waste is it produces carbonized material, liquid product and biogas product. These are the contents of each product. The carbonization of organic waste using superheated water vapor has been studied and done before this by Sewerage Bureau of Tokyo. They used sewage sludge as their raw material. This figure shows the Bureau selling the product of carbonization as an alternate fuel of coal for thermal power generation plant. The problem statement for this project are: activated sludge disposed in landfill increases the production of methane gas and release to environment. As we know, methane gas is very harmful as it is one of the greenhouse gas. Disposing the activated sludge into landfill consumes a lot of volume. And finally, the activated sludge being dumped at the landfill is not fully utilized despite its potential in fuel production. The objectives of these projects are to develop a new method of producing carbonized fuel from activated sludge, to find the best operational condition of superheated carbonization process, and to study about the heating value of the fuel produced. The methodology for this project is briefly stated here. First, the raw material should be prepared. After preparing the raw material, it should be dried in oven. Once drying is done, moisture content calculation will be done. This is because the moisture content value will be used in finding the yield. After that, carbonization process will be done, and finally product analysis. This is the equation used to find the moisture content, where MC is the moisture content, WW is weight of sample before drying, WD is weight of sample after drying. This is the setup of rotary kiln carbonizer. It consists of an evaporator, right furnace, rotary kiln carbonizer with furnace, left furnace, and the cooling part. Before the experiment starts, the dried activated sludge should be put into the rotary kiln reactor and set up as in the figure. Deionized water will be pumped into the evaporator. The evaporator at 300 degrees Celsius will convert the deionized water into superheated water vapor. The superheated water vapor flows into the right furnace, and then it flows into the reactor. It decomposes the activated sludge, leaving behind carbonized solid. The product gas will be leaving the reactor into the left furnace and then to the cooling part. The condensed liquid will be collected in beaker 1, while the non-condensable gas will be collected in beaker 2 by using water displacement method. This is the operating temperatures of reactor. This is the operating temperature of reactor. From room temperature, heating up to 250 degrees Celsius, which will take about 2.5 hours, and then the reaction time is about 1 hour, and after that cooling back to the room temperature. So I planned to manipulate the temperature by 250, 300, 350 and 400 degrees Celsius by making constant the reaction time to 1 hour. For the product analysis, the yield of solid product will be calculated using the yield equation, where Y is the yield of carbonization, WCM is weight of carbonized material, WW is weight of wet sample, and MC is the moisture content, which we calculated before this. Then it is analyzed using CH&S analyzer, and after that finding the heating value using bomb calorimeter. For liquid product, it is analyzed using high performance liquid chromatography, or we called it as HPLC, while for gas product we analyze it with gas chromatography or GC. The expected outcomes for this experiment are: the yield of carbonization decreases as temperature increases, and the carbonized material can be used as fuel. These expected outcomes is based on the journal I found. And then this is the Gantt chart for semester 1. Semester 1 mostly focus on thesis writing on chapter 1, 2, 3 and the understanding of the topic. So the work is mostly done for this semester, And for semester 2, I planned to finish the lab work by week 7 and focus on product analysis, calculation, and then focus on thesis writing. So that's all this presentation is about. Thank you.